Hi, this is a bit more detailed explanation of the performance of the system with some sort of graphs while the system's running over here. So what the graphs show is pressure. So the green and the red line here shows pressure over time, and it never quite goes down to zero because we've got a PEEP valve. So at the start of the inhale breath it rises up and tries to maintain a constant pressure through the inhale stroke, because we're running pressure controlled ventilation, PCV, and at the end of the inhale stroke the pressure drops, the arm comes back up and the pressure drops back down to the PEEP pressure, which is about 10, which is sort of roughly at 10. The PEEP valves aren't sort of perfectly accurate, so it's actually more like 8 on the PEEP valve I've got. The yellow orangey sort of line here, this is the motor speed, so it fluctuates a little bit to try and maintain a constant pressure, and the reason it kind of jumps around and is quite granular like that is because it's based on a restriction from the resolution of the sensor. It's kind of jumping from one sensor reading to the next, but it's still good enough to stay within tolerance. And on tolerance, it's currently set to run at 20 centimetres of water. You see the 20 on the side of the screen, and in the requirements document it says there's a tolerance for which it has to achieve the pressure that's set, and that tolerance is, I forget what it is exactly, it's something like plus or minus 2, a reading of 2, plus 4%. So I've put the lower tolerance band for the plateau pressure here in the purple colour. So there's also a reflected upper tolerance value, which I haven't mapped on here, but you can kind of work out if the lower one's that distance away, then the upper one's going to be about that distance away. So as long as the plateau pressure is always between the purple line and sort of the imaginary opposite purple line, then we're always within the tolerance. So you can see at the moment, based on the pressure readings I've got, we are within the tolerance right now. The tolerance for the peak pressure is a little bit higher, so you can sort of increase that band up a little section, and that kind of reflects where the peak band is. So with that all explained a bit quickly, I'm not sure if that's too quick, but with that all explained, I'm going to change some of the parameters on the machine and we can see how this responds. So just quickly over to the display. We've got this set pressure value that we can turn up and down, and we can see how that reflects the peak pressure that's being read to the screen. So I put this at a value of 30, then the peak pressure reaches about 31, which is okay, and then back onto the screen over here. So you can see that the pressure values are much more now, so it's trying to maintain a value of 30 for the pressure, and the tolerance band has expanded a little bit because that's what it says to do in the requirements. We're still within the tolerance. While looking at this, I'm going to change the pressure value again to go up to the programmed maximum, which is 45. So you can see that rising up here. Then the machine sort of tries to catch it up. The amount of time that it can spend at the maximum pressure is shorter up here, because it takes physically longer for it to get to that pressure, because there's more sort of volume to pass through to reach that same pressure. But that's fine. And then reducing the pressure back down all the way to the minimum that the device is set to, which is 15. We've just got an alarm going on because the minimum tidal volume alarm has been triggered, so I'm just going to reduce that alert limit. So we can see at 15 centimetres of water it's still maintaining in that plateau pressure. The peak pressure is certainly higher. It might droop down a little bit over time, but and that peak pressure might be out of the tolerance for the plateau pressure, but the idea is that it still is within the tolerance band for the peak pressure, which is slightly higher, although I haven't drawn it on the screen at the moment. So I'll just increase that back up to 20 again, like it was when we started. And then, as I described in a previous video, I can't properly change the compliance and the resistance settings of the lung because I don't have a proper test lung. Instead I'm using one of these with an APL valve, which is a pressure relief valve, and by changing the settings on the pressure relief valve it kind of gives the gives a simulated effect of changing resistance on a lung, but it's certainly not perfect. So it's turned all the way closed at the moment, but if I release that, then a bit of pressure gets released, and you can see on the screen that it still tries to respond to that and still tries to maintain it at a constant pressure level. So releasing the valve even more until the valve's completely open. So the valve's now completely open and all the air's coming out, and this isn't deflating properly now, but still returning to the peak pressure. And it's still able to maintain the pressure that we need, and then turning all the way back up to the maximum again. And it might take a little bit of time for it to reinflate back to the volume it was at before, but we're still able to maintain that high pressure, which is really good. The way that it's maintaining this is through a PID loop, so proportional integral differential control loop, and that wasn't super straightforward to program, but partly because the PID values had to change when the pressure was changing. So it's an adaptive PID loop where the values change depending on what the pressure is that's coming in. But it seems to sort of work okay. There's definitely some refinement to be done, which I'll be doing over the next few days. Yeah, any more questions, leave in the comments, thanks.